and then we proceeded to
This call is now being recorded.
then
This call is now taking notes.
talk about the orders of a matrix. We talked about the orders of a matrix. From the orders of a matrix, we talked about the element of a matrix. And then we proceeded to the addition and subtraction of matrices. Addition and subtraction of matrices. I think that was where we stopped the other time. As we also looked at the scalar multiplication of matrices when we use scalars to multiply a matrix and then thereby changing the elements in the matrix. So today we shall progress into the multiplication of matrices. We'll be looking at multiplication of matrices today. So multiplication. This is the general multiplication. You know, the other time, what we did say it was the scalar multiplication of matrix. So today we shall be looking at the general multiplication of matrices, the general multiplication. So let us say that we have two matrices. Let's say this is matrix A. Let's say matrix A contains element 2, 3, 4, 5. So this is matrix A. And then we also have matrix B. Let's say matrix B contains the element 3, 6, 7, and 1. So we have these two matrices, matrix A as illustrated there, as given there, and then of course matrix B, which you can see here. The question now says, what is A times B? What is the product of A times B? A times B. That you have to find A times B. Find A times B. So what this means is that you have to use the matrix A to multiply the matrix B. The matrix A multiplies the matrix B. Now, who has an idea? Because you must have done this before now. Who has an idea on what to do when you are multiplying two matrices, not scalar multiplication? This isn't scalar multiplication. What do you do when you have to multiply two matrices as illustrated here? Who has an idea?
I have some.
All right, so let's hear you.
Okay. For me, I guess you use 2 to times 3, use 4 to times 7, use 3 to times 6, use 5 to times 1.
You got the first part. You did get the first part, but then when you proceeded, there were errors in your explanation. Yeah, but we'll give that to you for the first part. The other parts actually weren't correct. So what you do is that, you see, let's try to give an illustration here. When you're multiplying matrices, you have to use the rows. Remember, the rows are the horizontal parts. You have to use the rows to multiply the column. You use the elements in the row to multiply the column. That's what you do. The element in the row times the element in the column. So just like the young lady just said now, we are to do this. We'll say that the 2 has to multiply 3 first. So our A times B would be A times B equal to draw a bigger bracket there. You say 2 times 3 here, 2 times 3, and then plus 4 times 7, 4 times 7. So the elements in row 1, the first row in matrix A, the elements there will multiply the elements in the first column in matrix B. So you see 2 will times 3 and then 4. You don't multiply straight, you multiply horizontal times vertical. That's what you do. Horizontal times vertical. That was why I did this the other time. I said this times this. Horizontal times the vertical is what you do. So you see here, 2 times 3, 2 in the first matrix, matrix A, will times 3 in matrix B, plus 4 in matrix A will times 7 in matrix B. So that is for the first part. Now there is another column. If you look at matrix B, there are 2 columns. So now that you have used row 1 to successfully multiply column 1 in matrix B, there is another column in matrix B, so you proceed. Again, you say 2 times 6, give space between this your first result here. You give space. And then you say 2 times 6 here. 2 times 6, you see there, 2 times 6 plus 4 times 1, 4 times 1. So if you look at this, you see that what we just did was that we used the element in the first row in matrix A to multiply the elements in matrix B, the column in matrix B. In essence, if there's just one column in matrix B, we would have multiplied just once. But the fact that there were 2 columns in matrix B, the role of matrix A, row 1 of matrix A, had to multiply column 1 of matrix B and also had to multiply column 2 of matrix B. You look at what we just did, 2 times 3 plus 4 times 7. Then we proceeded, because there's another column, we proceeded and said 2 times 6 plus 4 times 1. So now if you look at this, we'll see that row 1 in matrix A has successfully multiplied the 2 columns in matrix B. There is no third column in matrix B. I hope you remember what is meant by the row and the column. Do you all remember what is meant by the row and columns? Hello, I need you to reply me. Do you remember what the row and column meant from the last class? Hello? Does everybody remember what the row and the column stands for?
Yes, sir.
Yes, sir.
All right. So now what we're doing is that the row of matrix A has to multiply each column in matrix B. The row of matrix A has to multiply each column in matrix B. Until you're done multiplying each column in matrix B by the first row in matrix A, don't go to the second row. Until you finish multiplying the row 1 of matrix A by the columns of matrix B, don't go to the second row. That's why we did here 2 times 3 plus 4 times 7. There was another column, so we proceeded 2 times 6 plus 4 times 1. So now we're done with that first row of matrix A. It is now the turn of the second row. So the second row will repeat the same thing that the first row just did. In the second row, we'll have here we'll have to bring this down a little bit. We'll have 3 now. 3 and 5, that's the second row in matrix A. You have to use 3 to times 3, 3 times 3 plus 5 times 7, 5 times 7. So now you see we're now in the second row of matrix A. We are done with the first row. Now we went to the second row. We said 3 times 3 plus 5 times 7. And there is still another column. You see there that there is still another column. So we have to proceed again and say 3 times 6. This space here, you say 3 times 6 plus 5 times 1. 5 times 1. In the second row of matrix A, 3 times 3, we have it there, plus 5
Sir, please.
times 7. Do you have a
Sir, I'm not
question?
seeing. I'm not seeing the screen.
You can't see the screen?
Yes, sir.
Oh, okay, I'm coming. Well, the screen is still shared.
I'm not seeing the board.
The screen is
Okay. Okay, I'm seeing it now.
okay. All right. So, like I was saying, I said that the essence of this multiplication, because students find it confusing actually, the essence of this multiplication is that the rule in matrix A, the first row in matrix A has to multiply each column in matrix B. So if we start this all over again, you see in matrix A, the first row had elements 2 and 4. So we said 2 in this matrix A times 3 in matrix B plus 4 in matrix A times 7 in matrix B. That's what we got in the first part. Then we proceeded and said 2 times 6, because that's another column, so we have to multiply that too. 2 times 6 plus 4 times 1. So if you look at that, you see that the row 1 of matrix A has successfully multiplied through the 2 columns in matrix B. Then we proceeded to the row 2 of matrix A. Then we said 3 times 3, we got this, plus 5 times 7. There is yet another column, so we say 3 times 6 plus 5 times 1. Do you understand this, what we have here?
Sir, please come again. My network is. I never.
Okay. What about the other persons? Let's hear from the other people first and then we know how to go about it. Does everybody understand these arrangements here? Why we have these arrangements here?
Sir, please come again.
I beg your pardon.
Please come again, sir.
Okay. All right. All right. So let's look at something. Let's forget about this. Let's look at something here. When you are multiplying matrices, let's look at these two matrices. Let's say 4, 5 times 3, 2. Now let's see how to multiply this matrix. So this is what you do when you have to multiply a matrix like this. Pay attention to this because it is the same knowledge you will use at the other part. Maybe I should have started with this
So I don't
instead.
understand
You will
anything. No.
use, yes, we are trying, students actually have difficulties with this multiplication. We'll look at it, just pay attention, and I hope your network is good enough to capture the whole stuff. We're starting again. Look at this now. Look at what we have here on the board. The 4 times 4, 5 in the first matrix times in the column in the second matrix 3, 2. You use this 4 to times 3. You use 4 to times 3, and then you use 5 to times 2. You use 4 to times 3 plus you use 5 to times 2. Do you understand this illustration?
Yes, sir.
4 times 3, 4 times 3 plus 5 times 2, like this. 4 4 times 3 plus 5 times 2. This is what you do. 4, the first element in this first matrix, times the first element of the second matrix, the column there, 4 times 3 plus 5 times 2. Do you understand?
Yes, sir.
Okay, now let's try to proceed from this. Let's try to proceed from this. Let us say we now have something that has 2 columns. Let us say 4, 5 times, that's multiplying 3, 2, 1, let's say 1, 6. Let's look at this one now. This first matrix with one row, 4 and 5, multiplying another matrix that has 2 columns. So again, this is what you do. Again, just like this other one, you do this, you say this 4 will multiply 3, this 5 will multiply 2. You add them together. So 4 times 3 plus 5 times 2. 4 will times 3. The next number 5 will times 2. So you're multiplying row times column. Row times column. Now when you finish doing that, you see that here you have 4 times 3 is 12. You have 12. 4 times 3 you have 12 plus 5 times 2 you have 10. This is what you have in the first part. 4 times 3, 12 plus 5 times 2, 10. Now there is another column at the front. There's another column which is 1 and 6 in that column. So again you will proceed and say 4 times that's 1, 4 times 1, and then 5 times 6, 2. 4 times 1, and then 5 times 6 added together again. Here, 4 times 1, 4 times 1 there would give you 4 plus 5 times 6 will give you 30. So this is what you do. If you have more than one column, it means that you have to multiply more than one. So you multiply the number of columns you have. So 4 times 3 in the first one plus 5 times 2. That gives us 12 plus 10. That will be 22. Then when you proceed to the other one, because there's another column, you still have to repeat what you just did. 4 times 1, that gives you 4, plus 5 times 6, that gives you 30. Do you understand it now?
Yes, sir.
I need the others to answer. Does everybody understand how it's done now?
Yes, sir.
Okay,
Yes, sir.
because we do know that this multiplication has always been a challenge with students. It has always been a challenge with students, but then our purpose here in the class is to end that challenge today. Before today's class, I had known that it would be a lot of talk, but then I was already prepared for it. So this is how it's done. These are just rough work. Now let's try to take another proper work and see why we did these things we did here. Why did we then say in this example, why did we say 2 times 3? It's because of what we just did here. 4 is multiplying 3 plus 5 is multiplying 2. In the same vein, you see here that 2 is multiplying 3 here in this first example. 2 is multiplying 3 plus 4 is multiplying 7. That's that. Then because there's another column, we have to proceed and say 2 multiplies 6 plus 4 multiplies 1. That's what we had at that top. Then coming down, we're done with the first row. Coming down, the second row, 3 and 5. It will repeat the same thing that the first row just did. That is 3 times 3 plus 5 times 7, as you can see there. Then there's another column, so how to say 3 times 6 plus 5 times 1. That's what we have here. So does everybody understand why we have these numbers here now?
Yes, sir.
Yes, sir.
Everybody understand? That's just one person replying.
Yes, sir.
Okay, so now let's take another question. Let's take another question so that we'll have to be very sure that these whole issues with multiplication ends today in the class. Let us say that we have, let's say that we have a matrix P to be 2 and 4. Then we have matrix Q to be 1, 2, 3, 5, 7, and let's say 6. So now we have matrix P, that's matrix P, just one row, and then matrix Q as illustrated there. Now let's see if we can find PQ. Find PQ. Find PQ. So this is what you do in case if it seems that congesting the whole stuff together is difficult for you. In case doing everything together happens to be difficult for you, I would suggest you do this. You break this down one by one. For people who have issues with when work are congested, this is what you should do to solve this whole issue. Just simply say break this down. Say 2, 4, multiplying, take only your first column, multiplying 1, 2. Take only your first column. P times Q, take your P, multiplying, in your Q, take only the first column, that is 1 and 2. Then now multiply. Remember how you multiply. You multiply by saying that 2, you see it here, you say 2 times 1 plus 4 times 2. So here, you simply say 2 times 1 plus 4 times 2. And then the result you have here is 2 times 1 is 2, 4 times 2 is 8, so this gives you 10. So that is the first answer you have. Then you will proceed. There's another column, you have another column, 3 and 5. So you will proceed and say this same 2, 4 times 3 and 5. You do the same thing. 2 is multiplying 3, 4 is multiplying 5. To do that, you have 2 times 3 plus 4 times 5. When you do this, the result is 2 times 3 is 6, plus 4 times 5 is 20. The result is 26. So that's the second one. Then if you look at that, you see that there's yet another column. There's yet another column. So you have to continue. There is one last column, 7 and 6. So you have to repeat this again for 7 and 6. So again, we proceed and say 2, 4, 7, 6. Same thing, 2 is multiplying 7, plus 4 is multiplying 6. So here we have 2 times 7 plus 4 times 6. So 2 times 7 is 14. 4 times 6 is 24. 14 plus 24, that gives 38. So that answer is 38. Now you see that we are done with all the multiplication. You can see that P has successfully multiplied every single column in Q. We did the first one, P multiplying the first column, 1 and 2. P multiplying the second column, 3 and 5. P multiplying the third column, 7 and 6. Now it is time for you to bring back all these answers together to form the matrix PQ, because you're told to find PQ. You bring out all of them together to form the matrix PQ. And your PQ here would be the matrix. See, this is your first column. That your first answer when you multiply the first column 1 and 2. Your answer is 10. So your matrix there, that first part, 10. Give space. You have 10. Then see the part where you multiplied the column 3 and 5. The answer you got there was 26. So here you have 26. Then lastly, see the part where you multiplied the column 7 and 6. The answer you got was 38. So here you have 38. So this is the answer when you multiply P times Q. Do you understand this now? Do you understand it now?
Yes.
Do you guys prefer breaking it this way, or you would rather just solve directly? Because breaking it this way, it's more explanatory, but then it also takes your time. It takes your time. So what do you think about this?
We prefer this way.
Okay, but what
I
if
prefer the other one.
you prefer the other one?
Yes, sir.
Okay, so what I would advise you guys to do, what I would advise you guys to do is this: practice with this pattern where you have to separate them. Practice with this pattern where you have to separate them. But if you have to, if you are in an exam situation, doing this would waste your time because it's something you're just supposed to show directly like this. It's something you're supposed to show directly like this, you see. So when you begin to separate them, it takes your time, and the time you would have used to finish what you had to do, you have to be, you still be on it and stuff. So the best thing for you to do, practice with this method and know it very well. Then when you're very good at it, I would advise you use the other method, this method, to get it done. I advise you use this method now to get it done. So now we are going to take a multiplication problem, and I want you guys to do it yourself and you tell us the result that you got. So let's look at this. Let's say that we have um, matrix M. Let's call this a classwork. I'll have to leave the multiplication. Let's say we have matrix M. Matrix M to be 3, 4, 2, 1. So this is matrix M. And let's say we have matrix K to be equal to 2, 1, 5, 3, 2, 4. Now I need you guys to look at this. Do you think M times K is possible?
No, sir.
Why?
Because
Why?
hmm, Jesus Christ. How am I to explain myself? E no go fit work. It's impossible.
Okay, so explain why is MK impossible? All right. So let me help you with that. It's actually impossible, but let me help you
How?
with that. MK is okay. Does someone want to try?
Impossible. It's possible.
Does anybody want to try? Is there anyone who wants to try? The reason why MK is impossible.
No, sir.
All right. So MK is actually impossible because you are supposed to use each element in the row to multiply each element in the column. So let us try to pick only one row and one column first. Let's try to pick just one row and one column. Let's say the row 3, 2 and the column 2, 1, 5. Let's deal with this. Let's say this row and this one 215. Let's see why it is impossible. So we are picking only one row and one column first to see the reason why it is impossible. Now remember that we used to say that 3 times 2 plus 2 times 1. So now what will multiply 5? Because there is a 5 there. We are supposed to have each element being multiplied by another element in the row. And now we have just 3 times 2 plus 2 times 1. Then what will multiply 5? There is no other there that we can use to multiply 5. And since there is no other element I can use to multiply 5, then we say that MK is impossible. MK is impossible because there is no exact number. The number of elements in the row does not equal to the number of elements in the column. For you to be able to multiply, the number of elements in the row must be equal. The number of elements in the row of M must be equal to the number of elements in the column of K. So the row must equals to the column. That's when you can multiply. Do you understand? Do you guys understand?
Yes, sir.
Why are the other persons not replying? Does everybody
Yes, sir, we
understand?
understand.
These are recurring questions
Yes,
in
sir.
the SR writing.
Yes, sir.
Okay. All right. So now let's proceed to determinants of matrices. Let's proceed to determinant of matrices. Determinant of matrices. All right. So now we're looking at the determinant of a matrix. This one actually doesn't have so much of a problem because it just directs. If you have a matrix, let's say, if you have a matrix, let's say um, matrix P is equals to 3, 2, 5, 6, for instance, and you're told to find, this is a symbol for determinant. Once you see this, it means you are to find the determinant. Once you see these lines bordering P, once these straight lines are bordering P, these parallel lines are bordering P, then you know that they're asking you to find the determinant of P. Find the determinant of P. So when you're looking for the determinant of P, all you need to do is to say you multiply the first diagonal minus multiply the second diagonal. Multiply the first diagonal times the minus multiply the second diagonal. The diagonal here means you should multiply 3 and 6 together minus multiply 2 and 5 together. Please always start from 3 and 6. 3 times 6, it has to be the first diagonal minus the product of the second diagonal. So here your determinant should be um, your determinant here should be determinant of P here should be, you say 3 times 6 minus 2 times 5. The determinant, you say 3 times 6 minus 2 times 5. Don't forget, the first diagonal is the one you have to multiply first. The first diagonal is 3 times 6. That's the product of the first diagonal. So please take note. And then here, the determinant would be 18 minus 10, and then the result here should be 8. 18 minus 10, the determinant here would be 8. So this is how you find determinants of matrices. Just the product of the first diagonal minus the product of the second diagonal. So now let's take another example and with negative numbers. Let's look at an example that would have negative numbers among them. So let's say example 2. Find the determinants. Find the determinants. Find the determinants. Let's say we have minus 8, 3, minus 4, minus 6. Find the determinant of this matrix. Find the determinant of this matrix. Have minus 8, 3, minus 4, minus 6. So what do we do here? Who will guide us through? What do we do here? Who help us with this? Someone help us with this. Find the determinants of this matrix. Hello, are you guys still here? I can't hear.
0.
All right, so would you want to help us with this?
That's in my mind though, like minus 8 times 3 from minus 4
Minus 8
times
times what?
minus that this other one they talk for my job.
Minus 8 times what? Then minus 8 times what did you say? All right. So what you do here, the determinant would be, you say minus 8 times minus 6, minus 8 times minus 6, minus 3 times minus 4. Minus 8, the product of the first diagonal. Do not forget, it is always the product of the first diagonal. The first diagonal is minus 8 times minus 6. Don't go starting by multiplying 3 and minus 4. 3 and minus 4, that's the second diagonal. That's the product of the second diagonal. So the first diagonal is minus 8 times minus 6. Then minus the product of the second diagonal, which is 3 times minus 4. So if we proceed here, we would be having minus 8 times minus 6 would be 48 minus 3 times 12, and 3 times minus 4 is minus 12. Minus 8 times minus 6 is minus 48. Then minus 3 times minus 4 is minus 12. Of course, you know that minus times minus, you see that bracket there when you have to open the bracket. Minus times minus gives plus. So this is actually 48 plus 12, which is equals to 60. So the determinant of the matrix is 60. Does everybody understand this? Does everybody understand this? Does everyone understand this?
Sir, please, can you come again?
Okay, from this first one, is it the first one or this second determinant with minus 8, 3, minus 4, minus 6?
Yes, from the second one.
Okay, from the second one. All right. So to get the determinant, you have to multiply. Let's start from this first one. It will help you from the first one. Look at the first one. We have P is equals to 3256. Find the determinant. So what you did, you said 3 times 6 minus 2 times 5. 3 times 6 minus 2 times 5. Then 3 times 6 gave us 18 minus 2 times 5, 10. That's how we got 18 minus 10 to be 8. Now in example 2, said find the determinant. Minus 8, 3, minus 4, minus 6. So again, what you have to do is that you still have to use 8 to times minus 6, and you still have to use 3 to times minus 4. So 8 is like you're cross multiplying, something like that, but not actually. So 8 minus 8 times minus 6, then 3 times minus 4. That's what we did here. That's how I said the determinant is minus 8 times minus 6 minus 3 times minus 4. That is the product of the first diagonal minus product of the second diagonal. For minus 8 times minus 6, the result is 48. For minus 8 times minus 6, the result is 48. Then minus, that's the actual subtraction. Then 3 times minus 4 gave us minus 12. 3 times minus 4 gave us minus 12. And now we have 48 minus bracket minus 12. And minus times minus, because that bracket there means you're multiplying. So minus times minus, when you open the bracket by expanding, minus times minus changes into plus. That's why we have 48 plus 12 to give the result as 60. Do you understand it now?
Yes, sir.
All right. So this is what this is what you do when you are asked to find the determinant of a matrix. These are recurring questions in the WAEC and NECO and whatever you're preparing for. These are recurring questions. There is no year that these questions don't come out. So I want to advise you guys, as much as you're having these classes, do well to also take your time to study every day, even if it has to be just maybe an hour and 30 minutes or 2 hours. Try to always, give yourself some sort of a challenge every day that you have to read for 2 hours. It will help you a whole lot because you'll be sitting for the exams yourself, as you already know, and then no one is coming to save you. So you have to prepare as much as you can, for these exams. You have to be serious. Please be serious. Then this is what we had. This is for the determinant. Do not forget first diagonal multiplying themselves minus second diagonal multiplying themselves. So you subtract them. Always start with the first. If you start with the second diagonal, your answer will be wrong. Make sure it is minus 8 times minus 6 first. Then before you times the other one and subtract. All right, so this is for the determinant of a matrix. Now we will go to the transpose of a matrix. We still have transpose, we have inverse of a matrix. So let's try quickly see how we can look at the transpose of a matrix. Transpose of matrices. So this is what we're looking at now. Transpose of matrices. You see, this transpose is actually denoted by symbolic logic, the transpose itself. Like something like this. If A is a matrix, if okay, let's say if P is a matrix, then the transpose of P the transpose of P is P the transpose of P will be P raised to the power of T. This is the transpose. So when you're given a question and you're saying raised to power T, just know that they're asking you for the transpose of that matrix. If P is a matrix, then the transpose of matrix P is P to the power of T. If A is a matrix, the transpose of matrix A is A raised to the power of T, T for transpose. So once you see a raised to the power of T, know that they're asking you for the transpose of the matrix. Now, what is the transpose of a matrix? It is very simple. It has no calculations actually, except when it is now applied. But ordinarily on its own, there are no calculations. Let us say that we have matrix K. I have matrix K as minus 1, 2, 5, and 0, for instance. Matrix K is minus 1, 2, 5, and 0. And then you're told to find K raised to power T. Find K raised to power T. The moment you see that raised to the power T, you just know that they are asking you for the transpose of matrix K. What do you have to do to get the transpose? The transpose is gotten by simply interchanging the rows and the column of the matrix. This is the original matrix, matrix K. Mine is -1, 2, 5, 0. That's the original matrix. -1, 2, 5, 0. But then the transpose of this matrix is you simply interchange the raised to the rows and the column. Look at this now. At first in matrix K, our row 1 was -1 and 2. At first in matrix K, our row 1 was -1 and 2. But when I want to write the transpose, instead of me writing -1 and 2 as a row, I write -1 and 2 as a column. Instead of me saying -1 and 2 as a row, I will change that -1 and 2 that used to be a row, I will write it as a column. And then the 5 and 0 at the bottom that used to be the second row, instead of me writing it as a row, I'll change it to a column and say 5, 0. So this is the transpose of the matrix. You simply interchange the rows and the column. You're simply interchanging the rows and the column. What used to be a row before, you change it to a column. What used to be a column before, you change it to a row. Simple. There are no calculations, except if you have to apply, because sometimes you can now say find the product of K and the transpose of K. So that's an applied question. So in that case, you have to multiply. But ordinarily, transpose of K is just simply interchanging the rows and the column. Let's look at another example of a transpose. Let's say example 2.
I'm not seeing it, sir.
Both me.
You can't see the board. You can't see the board.
Check your network.
But now I
Check
can
your
see it
network.
now.
Maybe it's your network.
Can other people see the board? Can others see the board?
Yes.
Yes.
Okay, it's sometimes the network issue. Recently, I actually don't know. Recently, the network has been really bad almost everywhere. So I don't know why it could be network problems since others can see the board. So it's possible that your network isn't all that strong presently. All right, so that's by the way. Let's try to look at another example of a matrix and determine the transpose of that matrix. So let's look at this. Let's say example 2. Let's say we have a matrix. What do we call this now? Q, for instance. Let's say matrix Q is 4 minus 3, 2, 6, 8, 1. Find q to the power of t. Find q to the power of t. That q to the power of t is actually saying find the transpose of q. So these are majorly objective questions though. Find the transpose of q. The original matrix is q equal to 4 minus 3, 2, 6, 8, 1. Find q to the power of t, meaning find the transpose of q. Remember, like I've said, the transpose of a matrix simply means changing what used to be a row, you change it to a column. And changing what used to be a column, you change it to a row. So this is what you do here. Transpose of Q is equals to, if you look at this, you see that our row 1, remember the rule is the horizontal one. Our row 1 used to be 4 minus 3, 2. It used to be a row 4 minus 3, 2. But when we're looking for the transpose, we will change it from being a row into a column. So instead of saying 4 minus 3, 2 as a row, we'll say 4 minus 3, 2 as a column. Instead of saying 4 minus 3, 2 exactly as it is as a row, we'll say 4 minus 3, 2 as a column. Then the second row at the bottom that used to be 6, 8, 1. The second row at the bottom that used to be 6, 8, 1. Instead of maintaining it as a row, again we will change it into a column. And then we say 6, 8, 1. So this is the transpose of the matrix. This is the transpose of the matrix. You overturn it, you change the row, you turn it into a column, or you change the column, change it into a row. So this is what you do when you are told to find the transpose of a matrix. Do not forget the difference between some students mistake determinant and transpose. The determinant is different. The determinant is the one where you have to times the first diagonal times the second diagonal and subtract them. So it is the difference between the product of the first diagonal and the second diagonal. That is a determinant. So either they tell you find the determinant, or they'll give you a symbol like this, find, you see those parallel lines, P at the bottom, at the center. That's if the matrix is P. If it is A, it will be A that will be at the middle here, this one here. It will be A that will be at the middle. If it is Q, it will be Q that will be at the middle. So it's either they spell it out to you, they say find the determinant, they'll spell it, or sometimes they won't spell it out. They give you in symbols, by logic, in using symbols there. So you should know what these symbols mean. And please, like I have said for the umpteenth time, when you're looking for the determinant of the matrix, make sure it is the first diagonal you multiply first. 3 times 6, make sure that's what you multiply first, as it is illustrated there, minus 2 times 5. For the second one, make sure it is minus 8 times minus 6, you multiply first, minus 3 times minus 4. So make sure it is the first diagonal you multiply first. Then for the transpose, we said it's very simple. Just all you have to do is to change what used to be a row, change it into a column, change what used to be a column, change it into a row, and that is all you have to do. So when we looked at this first example, we had the first row was minus 1, 2, second row was 5, 0. Then for us to get the transpose of that matrix, we just said that row that used to be minus 1 and 2, we change it to column as minus 1, 2, as a column, no longer a row. Then the other row that used to be 5 and 0, we change it to column 2. The same way here, this Q, matrix Q, there used to be 2 rows. Matrix Q used to be 2 rows, but when we found the transpose of matrix Q. The new matrix we had, matrix Q transpose, now had 3 rows. But instead of saying 4 minus 3, 2
I'm
as
not
a
seeing this.
row, it would be your network. It would be your network. The screen, it should be your network. Can others see the board? Can the others see the board?
Yes.
Okay.
No.
All right. So um it's the board is still connected. So if you can't see the board, it will definitely be that you're having a lagging network wherever you are. But then the class would always be recorded and posted on the website, so you can always go back there and go through it. So that's by the way. This is a transpose. Then lastly, before we end the class, we would look at the inverse of a matrix. This is the last thing we'll be looking at before the class elapses. And please, I'll need to call the register and mark you present. So some of you, the names you answer here, some of you, like the names differ from what we have registered on the site. So please, when I'm marking it, I'll call your names and I would expect you to respond so I can mark you present in the class. That's before we end the class. So please do not leave the class before we mark the register. Then lastly is the inverse of a matrix. The inverse of the matrix is this is the last thing we'll look at here. All right, so the inverse of a matrix is also simple. It's very simple, but then just a little bit of work. Okay. If you have if you have a matrix and you're told to find the inverse of the matrix, all you have to do is, let us say we have that P is equal to 2, 1, 4, 7. P is equal to 2147. Find, this is the symbol for inverse, P raised to power minus 1. When you see this, a negative power of 1,
No, but no,
So please, I'm not seeing anything, no. And our assignments, the former one.
Nobody they say anything. You don't come out for class.
Yeah, well,
You don't know where teacher they teach they go.
Teacher don comot. Teacher don
You don't
comot.
come out,
David,
so I don't understand though.
Matilda,
I dey
Afana,
Matilda.
sir,
Aunty Matilda.
sir,
I just do. Where's the
sir.
winner?
I don't know what to you talk.
David,
My
oh,
network bad.
I dey
my own too. My network still bad. No, I not lie you.
all the network dey wait.
I tell na
My
rain wey
network
fall.
bad. Davis, now you be senior man, Abi.
Yes ma'am.
Who be that?
Na
David,
Nigerian
oh,
na Nigerian.
How
David,
you start up? You know the other tutor, none of them they online. None of them they this group. It's what they happen.
David, oh,
Guys na for us to
Yes,
go sleep abi. I dey
come on.
hear you
do
talking.
me stop, do me
abeg
stop. My son want finish.
May I come up for the group?
David, my son want finish.
Send me your number privately.
After now, I started with that man. I understand anything about English.
We understand that now.
Senior man,
Ma. Yes ma.
I don't know why today won't be like that too. On look now you go on Tuesday. You better
Yes.
find and David Ebose na dey talk and Lucky. Who's Ebose? Ebose.
I still
No,
understand today o.
we talk na dem dey talk. Nobody dey. Wetin Baba? No, Lucky.
I understand today o.
Na so dem say dey.
David, oh, David, oh, David,
Where dey am? Hey, back I dey na.
David don't come on. David, you why you? Oh, David don't run come out.
Me sef I wan comot.
More your way first now. Maybe the man will come back now.
I go check group.
Okay, you sharp. Put your come on too. So sir. I so sir.
It's praise.
Okay, no problem. How are you doing?
Yeah, are you?
Oh, it's how far now? Guys, I don't job.
I was like, you have forgotten.
Yeah, man. Oh, my network don't bad like this, so my network don't bad. My network don't bad. My network though bad. Whew. Okay now. I want to leave this place here. You might have come back home.
Okay, so hello. What
Ah,
was the last thing you guys saw? What was the last thing you guys saw? I didn't even know that the call had disconnected.
Ugandan.
What was the last? Where were we before the call disconnected? What was the last thing you saw?
Not aware. God to help me.
What was the last thing you saw? Did you guys understand the inverse or the call had disconnected by then?
Yes, sir.
Does everybody understand the inverse?
Yes, sir. But this one, I do not understand this last one.
This inverse.
Yes, sir.
Okay, so I said first thing, find the determinant. After finding the determinant, as you can see there, we found the determinant first. The determinant is 10. Then the inverse will be 1 over the determinant, 1 over the determinant. Then you will interchange your first diagonal. Instead of 2, in your first diagonal, it was 2 and 7. You interchange it to be 7 and 2. Your first diagonal. Instead of 2 and 7, you change to 7 and 2. Then in your second diagonal, you multiply it by minus. Your second diagonal, you multiply it by minus. That's why you have -1 and -4 there. Do you understand?
Okay.
All right. So let's quickly call the attendance first before let's quickly call the attendance. Please, you guys just answer your names. This is Daniel Nosayaba here. Daniel.
Daniel. No, no, no.
Okay. What about Judith? I am Judith.
No.
Mbaseki Matilda.
Yes. He attend.
Okay, if you don't marvelous.
No.
Sharon.
No, no.
Okay, Joshua. I no get now, Joshua.
Okay, now Joshua. I don't know. But he's not here.
Okay. All right. So um Sharon, okay. Osazuwa Logosa. What about this person?
This person. I don't know.
Osazuwa Logo. Oatman Jessica.